Welcome to my 24th tutoring session in A-level chemistry. In this video, I will give a brief and quick summary of the trends in the periodic table. Please take a moment to watch my previous videos on topics periodic trends in atomic size, ionization energies, electron affinity, and electronegativity. These videos will provide you with a better understanding of this video content. Links to these videos is given in the description below. Please do watch the videos. Don't forget to subscribe my channel, share, like, comment, and watch the full video. What is periodic trend? Periodic trend refers to predictable variations in the properties of elements across a period and down the group in the periodic table. Let me explain the periodic trends with respect to group 1 and period 2 elements of the periodic table. Now down the group, the shells increase. Hydrogen contains 1 electron shell, lithium with 2 electron shells, sodium with 3 electron shells, potassium with 4 electron shells, rubidium, cesium, and francium with 5, 6, and 7 electron shells respectively, which is not shown here. And going down the group 1, shielding increases. Why is that? Let's find out. As the number of shells increase, electrons also increase. I have color coded the electrons. The inner shell or inner core electrons are highlighted in red, while the valence electrons are highlighted in green. What is shielding? Shielding is a phenomenon which partially reduces or blocks the electrostatic force of attraction between the positively charged protons and the outermost valence electrons. So that is one aspect of shielding. The other aspect of shielding is that it repels the incoming electrons and prevents the atom from accepting the electron, and thereby the electron affinity of the element decreases. So with the increase in the size of the atom, the shielding increases, and with the increase in shielding, electrostatic force of attraction between the positively charged protons and the outermost valence electrons decreases, and it also repels the incoming electrons, decreasing the electron affinity of the element. What is effective nuclear charge? Now, effective nuclear charge is abbreviated as Z effective. It is the electrostatic force of attraction between the positively charged protons and the outermost valence electrons. Or it can also be defined as the net positive charge experienced by the outermost electron in a multi-electron atom. Now, as the shells increase, shielding increases, and as a result of shielding, there is decrease in attraction between the nuclear protons and the outermost valence electrons. So as you go down the group, number of shells increase. With increase in number of shells, shielding increases, and with increase in shielding, the electrostatic force of attraction between the nuclear protons and the valence electron decreases, and thereby the effective nuclear charge also goes down. Now I highlighted the core electrons in red, valence electrons in green, and the double-headed arrow highlighted in green refers to the effective nuclear charge. That is the attraction between the nuclear protons and the outermost negative electrons. And going down the group, atomic radius increases. Now atomic radius is the measure of size of an atom, specifically the distance from the nucleus to the outermost electron in neutral atom. So going down the group, atomic radius decreases. And with increase in atomic radius, ionization energy decreases. So what is ionization energy? Ionization energy is the amount of energy required to remove an electron from a gaseous atom. It is the measure of strength of attraction between the positively charged protons and the negative electrons. Now ionization energy decreases going down a group because as you go down the group, number of shells increase. With increase in number of shells, the size increases. With increase in size, shielding increases. And as a result of shielding and the increase in the distance, the electrostatic force of attraction between the nuclear protons and the outermost valence electrons also decreases. And the outermost valence electrons are loosely held. So let me explain comparing the ionization energy of potassium with that of sodium and lithium. So in case of potassium, it has a low ionization energy because of the distance. So in case of potassium, the outermost valence electron is far away from the nucleus and experiences a weak attractive force, and therefore it can be easily removed because the valence electron in case of potassium is loosely held or loosely bound. So in case of lithium, the amount of energy required to remove an electron is 520 kilojoules. In case of sodium, the amount of energy required to remove the outermost valence electron is 513 kilojoules per mole of energy. And in case of potassium, ionization energy is 419 kilojoules per mole of energy. So you can see as you go down the group, the ionization energy decreases because the valence electron in case of potassium is loosely held, while in case of lithium, the valence electron is tightly held, because in case of lithium, the valence electron is very close to the nucleus and therefore experiences a strong attractive force. So you have to provide energy now to remove the only valence electron in case of lithium, whereas in case of potassium, less amount of energy is required as it is loosely held due to the distance from the nucleus. And going down the group, though there is increase in shielding, there is also an increase in nuclear charge. So here, nuclear charge increases, shielding also increases going down the group, but increase in shielding wins over the increasing nuclear charge. So here, shielding wins the battle over the nuclear charge. So nuclear charge for hydrogen is 1 proton in case of hydrogen, 3 protons in case of lithium, 11 in case of sodium, 19 in case of potassium. As you go down the group, though the nuclear charge increases, the shielding effect wins. And effective nuclear charge decreases because as you go down the group, the size increases, and with increase in size, the distance between the nucleus and the outermost valence electron increases, and therefore with the increase in distance between the nucleus and the outermost valence electron, effective nuclear charge also decreases, which I've already explained. So effective nuclear charge decreases going down the group because of the increase in distance between the nucleus and the outermost valence electron. And metallic character and the ionic nature increases going down the group. So what is metallic character? Now metallic character can be defined as the ability of an element to lose an electron and form a electropositive ion. So this is because of low ionization energy. So metallic nature of potassium will be more than that of lithium because potassium has a tendency to lose electrons easily as compared to lithium, which is reflected from the ionization energy values. So less energy is required in case of potassium, while more energy is required in case of lithium to remove the outermost valence electron. So metallic character increases going down the group. And as the metallic nature increases, even the ionic nature also increases. So the metals easily lose electrons to form electropositive ions to form cations because of low ionization energy. So potassium easily loses its outermost electron to fluorine atom. So potassium is a metal, fluorine is a non-metal. So potassium loses electron to fluorine, that results in formation of electropositive potassium ion, and fluorine, after accepting the electron, it forms a negative fluoride ion. And electronegativity decreases going down the group. So what is electronegativity? So atomic electronegativity is the ability of atom to attract the shared pair of electrons in a chemical bond. So as you go down the group, the attraction for the element decreases. Why is that? Because of all the reasons what you have discussed so far, all the factors like increase in the number of shells. So with the increase in number of shells, atomic radius increases. With the increase in atomic radius, shielding increases. With increase in shielding, ionization energy decreases. And as a result, the effective nuclear charge also decreases. So this clearly shows that going down the group, the element will lose its ability to attract the electrons. So electronegativity of lithium is 1, sodium is 0.9, potassium is 0.8. And reactivity increases going down the group. So what is reactivity? Now reactivity is a measure of how easily an atom can lose a electron. So among these three elements, lithium, sodium and potassium, which element do you think will lose the electron easily? Yes, it is the potassium that lose the electron easily because of its low ionization energy, because of the factors what you have discussed so far. So potassium, it is more reactive than sodium and lithium because its ability to lose electron is more. So the ability of potassium metal to lose electrons is much more as compared to sodium and lithium, and therefore it is highly reactive. And therefore it reacts with fluorine to form potassium fluoride. And electron affinity decreases going down the group. So this is because of shielding, what I have explained in the beginning. So as a result of, there are two aspects of shielding. One aspect of shielding is that it decreases the electrostatic force of attraction between the nuclear protons and the outermost valence electron. That is one aspect of shielding. Other aspect of shielding is that inner core electrons, they repel the incoming electrons and therefore prevents the atom from accepting the electron. And basic nature of oxides also increase going down the group. Like sodium reacts with oxygen to form metallic oxide, that is sodium oxide, which in turn reacts with water to form basic sodium hydroxide. So basic nature of oxides also increase going down the group. So electron affinity of lithium is high as compared to sodium and potassium. So potassium has the least electro affinity. That is to say, it has a low tendency to accept the electrons. So these are the trends going down a group. Now what about the periodic trends across a period? Let's find out. So we have thoroughly examined the periodic trends down the group. Now let us examine the periodic trends across a period. So across a period, shells remains the same. So we are talking about the period 2 elements here. So period 2 elements will contain 2 shells, period 3 elements will contain 3 shells, period 4 elements will contain 5 shells. So period 2 elements contain only 2 shells across the period. Shielding is constant. So when you observe closely, you can find that the inner core electrons is constant. There are only 2 inner core electrons in the period 2 elements. But the number of valence electron increases. So there are two things that you can observe going across a period from left to right in periodic table. In the period 2 elements, the number of inner core electrons remains constant, that is 2 core electrons present in the first shell, while the number of valence electrons increases. So shielding is constant. So as a result of this, the electrostatic force of attraction between the nuclear protons and the outermost valence electrons will be more, because the valence electrons are very close to the nucleus, and atomic radius decreases as you go across a period. Ionization energy increases. So why ionization energy increases, and what is ionization energy? It is the amount of energy required to remove an electron from the atom, the gaseous atom. So as you move across the period, you can see that the nuclear charge increases. Beryllium with 4 protons, boron 5, carbon 6, nitrogen 7 protons, oxygen 8 protons, and fluorine contains a total of 9 protons. So as you go across the period, the number of nuclear protons increases, but the number of shells remain the same. So shielding is constant, but the number of nuclear charges increases, and therefore increasing nuclear charge wins over shielding. And as a result of increasing the number of nuclear protons, there is increase in the Coulombic force of attraction between the positively charged protons and the outermost valence electrons, pulling the valence electrons very close to the nucleus. And that is why you can see there is a shrink in the size of the atoms as you go across the period. So when you compare and contrast the size of fluorine atom with that of lithium atom, you can see that there is a drastic reduce in the size of the fluorine atom. So this is because of effective nuclear charge. So effective nuclear charge increases going across the period. Because of increasing nuclear charge, winning over shielding, and atomic radius or size of atom decreases, and the effective nuclear charge also increases. So all these factors collectively contribute to So decrease in size of the atom. And going across the period, the metallic nature decreases and covalency increases. So here, across a period, the metallic nature decreases. That is to say, the non-metallic nature increases. So what is non-metallic nature? Non-metallic nature is the ability of an element to gain electron to form a negative ion. So fluorine atom, it immediately or it gains electron with utmost ease to complete its outermost shell, and therefore the non-metallic nature increases as you go across a period from left to right in the periodic table. So not one factor, but all these factors collectively contribute to increase in the non-metallic nature going across the period. So to put in simple terms, as you go across the period, the non-metallic nature increases and the tendency for the element to gain electron increases to form a negative ion. And even the covalency also increases. So tendency of the element to form a covalent bond with other non-metals also increases. As you can see in some of the most important molecules like water molecule, oxygen molecule and carbon dioxide molecule. So these molecules are formed by formation of covalent bonds between the non-metals. So in case of water molecule, you can find the covalent bond is formed between oxygen atom and the two hydrogen atoms. In case of oxygen atom, two pairs of electrons are mutually shared between the two oxygen atom, resulting in formation of two covalent bonds. So covalence increases across a period. So what about electronegativity? So electronegativity increases across a period. So electronegativity is the ability of the atom to attract the shared pair of electrons in a chemical bond. So for example, hydrogen fluoride. So fluorine is a non-metal, hydrogen is also a non-metal. So a covalent bond is formed between hydrogen and the fluorine atom. But the electronegativity of fluorine atom is much more than the hydrogen atom. So fluorine atom has a electronegativity of 4, while hydrogen has a electronegativity of 2.1 on the Linus Pauling scale. And as a result, the fluorine atom, it pulls or attracts the shared pair of electrons close to itself, which is indicated by an arrowhead pointing towards fluorine atom. And as a result, fluorine gains a partial negative charge, while the hydrogen gains a partial positive charge. So here the electrons are not equally shared, but it is unequally shared. So the covalent bonds are two types. One is the polar covalent bond, other is the non-polar covalent bond. So in case of hydrogen fluoride, it is non-polar covalent bond. And because of the high electronegativity of fluorine atom, it pulls or attracts the shared pair of electrons, making it a polar covalent bond. So all the factors contribute towards increasing electronegativity of the fluorine atom going across the period. So electronegativity of beryllium is 1.5, boron is 2, carbon is 2.5, nitrogen is 3, oxygen is 3.5, fluorine is 4. So not one factor, so all the factors like there is increase in the nuclear charge, winning over shielding, atomic radius decreases, shielding is constant, effective nuclear charge increases. So all these factors collectively contribute to the greater ability of the element to attract the shared pair of electrons in a chemical bond. And reactivity increases. So how do you define reactivity going across a period? So reactivity is a measure of how easily element can gain electrons. So fluorine atom has the highest ability to gain the electrons among all the elements. So in comparison to lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine has the greatest ability to gain the electrons. And electron affinity increases going across the period. So what is electron affinity? So electron affinity is the energy change that occurs when an atom in the gaseous state gains an electron to form a negative ion. So it is a measure of atom's ability to accept an electron to form a negative ion. For example, fluorine atom, being the most electronegative element, it accepts the electron to form a negative ion. So because of all the factors what you have discussed so far. And acidic nature of oxides increase. So carbon, which is a non-metal, period 2 element, it reacts with oxygen to form carbon dioxide gas, and carbon dioxide gas reacts with water, it dissolves and form carbonic acid. So acidic nature of oxides also increase going across the period, like in case of carbonic acid, which is obtained on dissolving carbon dioxide in water. Thank you so much for watching my video. Hope you enjoyed it. I'll meet you in the next interesting tutoring session.